Okay, we're starting a new unit here. It's regretting moonlight rarity. And boy, this is a rarity to see the silhouette of a cow against a full moon. Wait a minute. Something's not in the right order here. I don't think we're studying that. Let's see what this unit's really about. Let's reorganize those letters. Okay, so the first word is actually right. And then triangle. And finally, trigonometry. Okay, so what we're actually studying is right triangle trigonometry. That's what the unit's all about. Now, I know we've done work with the Pythagorean theorem before, but we need to make sure we get this really, really down well. You don't have to use the letters A, B, and C, but that's what you'll see most often. And we don't have to have the right angle labeled C or the hypotenuse labeled C, but again, that's what you'll see most often. The legs are interchangeable. A does not have to be the shortest leg, right? Either leg could be A, either leg could be B. Hypotenuse, there's no choice though. The neat thing is when you get into Algebra 2 and pre-calculus, we won't just be using plain old numbers. Quite often you'll be asked to find a decimal approximation, but if the directions want exact value, then we better come up with an exact value. You probably have the answer to this one memorized already. You've seen it quite a few times. You know 6 times 6 is 36. 8 times 8 is 64. Those add up to be 100. Of course, square root, plain old 10. Now, gotta stay on your toes because we don't always add. Right? We start by squaring some numbers, but we don't always do some addition. Notice on this right triangle, we actually know the hypotenuse. We know the hypotenuse is 7. We're looking for a leg. So after I square the numbers, I have to actually subtract because I'm trying to isolate the variable. Opposite of adding 9 is subtracting 9. Of course, now I can take the square root. Of course, the square root of 40 does not come out as a whole number. Now, why am I choosing 4 times 10 instead of 5 times 8? Well, I can't take the square root of 5. I can't take the square root of 8. I need one of the factors to be a square number that I can take a root of. Square root of 4, of course, is 2. So we've got 2 root 10. Oh, this looks interesting. Of course, the square root of 37 squared is just going to be 37. That's the easy one. But what do I do with the 2 root 3 when I try to square that quantity? Well, I've got to take the 2 root 3, multiply it by another 2 root 3. Using the commutative property of multiplication, I can rewrite that as 2 times root 3 times root 3. 2 times 2, of course, is 4. Root 3 times root 3 becomes 3. So notice that square root of 37 was really quick to square. But when I have something like 2 root 3, it's a little bit more time consuming. Subtract 12 from each side. Oh, and look how nice this works out. Square root of 25 is just going to be 5. Now, the Pythagorean theorem only works if we know we have a right triangle. And if we know it's a right triangle, and we're given 2 of the sides, we can find the third. But what if we don't know the nature of the triangle? What if we don't know whether or not it's a right triangle? But we do know the 3 sides. What can we do then? Okay, a squared plus b squared does not always have to equal c squared. Now, notice that c will have to be the longest side of the triangle, but not necessarily a hypotenuse. Sometimes c squared isn't quite large enough. If c squared is less than a squared plus b squared, we're actually looking at an acute triangle. If c squared is a little bit too large, for example, if c squared is greater than a squared plus b squared, if angle c is too large, the triangle is obtuse. We only get equal c squared equals a squared plus b squared when it's a right triangle. So if I know the 3 sides, I can deduce whether or not I've got a right triangle, or an acute triangle, or an obtuse triangle. So let's take a look here. 5 times 5, of course, will be 25. 8 times 8 is 64. That adds up to 89. Well, what's c squared? 10 times 10 is 100. Uh-oh, 100 is greater than 89. C squared is too large. That means the triangle is obtuse. Notice I didn't try to take the square root of 89. I just said, okay, let's just compare it to c squared. Okay, 7 times 7 is 49. 9 times 9 is 81. Add those up, I get 130. Again, I don't have to take the square root. I just want to know, well, what's c squared? 10 times 10 is 100. 100 is less than 130. C squared is too small. It's an acute triangle. Well, 20 times 20. Now, you should probably be able to figure out 20 times 20 either with mental math or real quickly with pencil and paper. But when you get something crazy like 21 times 21, grab a calculator. 20 times 20 is 400. 21 times 21 is 441. That adds up to 881. Well, let's compare that to 29 squared. Now again, most of us don't go around memorizing something like 29 squared. Just grab a calculator. 29 times 29 happens to be 881. Holy cow, you look at that, it's an exact match. If it's an exact match, it's got to be a right triangle. And try as I might, it looks like I just did not leave enough room for a fourth example. Right, I thought it'd be fun to do one with a radical in there, so we're going to need a new slide. All right, so here we go. 6, 7, and then 2 root 21. Okay, so a squared plus b squared. 6 times 6, of course, is 36. 7 times 7 is 49. Add those together, I got 85. Okay, is c squared going to be 85, more than 85, or less than 85? Well, we're going to do 2 times 2 is 4. Root 21 times root 21 is 21. 4 times 21 is 84. Whoa, that's really close. But a little bit too small. 84 is less than 85. C squared is too small, so it's an acute triangle. Okay, still got plenty of room for examples. 9 times 9, what is that? 81. Now I know 4 times 4 is 16. So 40 times 40 will have to be 16 with 2 extra zeros. Okay, c squared. 41 times 41. Probably want to grab a calculator here. Amazing, an exact match. It's a right triangle. Okay, we still got tons and tons of room. So, right? Oh no. Come on. Okay, so I guess that we just wait a minute here. I don't know how I'm going to fit another example on here. Out of room. Darn it. No more examples. So instead, what is going on here? Aha! You're probably wondering about the IXL for today. As it's coming into view, it looks like it's going to be Q1. It looks like the Pythagorean theorem as it slowly comes into view. Again, if you can find the geometry tab, that's just fantastic. If you cannot find the geometry tab, for some reason it's called level L. When I just go to the website, I see geometry, but when I log on as an administrator, it tells me it's level L, so I never quite know what you're looking at as a student.